Let us see the next unit, states of matter, and particularly we have to see gaseous state. Let us see super 30 questions of this states of matter. Question 1. The density of monoatomic gas will be the highest at. Now density, monoatomic gas, maybe helium, neon, argon, highest at. Now look here, what are the options are in terms of temperature and pressure. Temperature and pressure. We know that density of any gas is directly proportional to pressure and inversely proportional to temperature. For highest density, pressure should be high and the temperature should be low. Let us solve this one. In this 1 upon 273 plus 273 546 STP condition, 1 atmosphere, temperature 273 Kelvin. Then here ऑप्शन सी में है 0 डिग्री सेल्सियस 2 एटमोस्फियर, ये 2 है 0 डिग्री सेल्सियस 273. डी में है 273 डिग्री सेल्सियस 2 एटमोस्फियर 2 अपॉन 273 डिग्री सेल्सियस means 546 Kelvin. Now let us see which ratio is the highest one. This is the ratio highest. Now look here, 2 upon 273, this is the highest value. That's why density of monoatomic gas will be the highest at 0 degree Celsius and at 2 atmosphere. High pressure, low temperature. C is the correct option. Second, at a given temperature 400 ml methane gas diffuses in 100 seconds. Whereas the 100 ml gas X diffuses in 50 seconds. The formula of gas X will be. Dear students, this question depends on Graham's law of diffusion. This depends on Graham's law of diffusion. What is the meaning of a diffusion? The spontaneous process of mixing of two gases to form homogeneous mixture is called as the diffusion. Then what is this? Graham's law tells us regarding here methane and here gas X. Or here see the statement. Rate of diffusion of gas is inversely proportional to molar mass of that gas. For the Graham's law of diffusion, rate of diffusion of gas is inversely proportional to square root of a molar mass of that gas. But question arises, what is the rate of diffusion? Rate of diffusion is nothing but volume of gas diffused per time, per second, is directly proportional to 1 upon root m. This is Graham's law. Let us see here gas methane and gas X. First we have to determine the molar mass of gas X. Then we will see what is the formula that suit. Let us solve this one. Volume of methane gas per time, here 100 seconds, upon volume of gas X upon 50 seconds. Now what is this volume of methane gas? 400 upon 100. Here volume of gas X 100 upon 50. This comes to 2 by 1. Let us solve this one. This will come to 2 by 1. Then this is of methane. This is of gas X. Then inversely proportional to means here is equal to here molar mass of X upon molar mass of methane. Let us solve this one. 2 by 1 is equal to molar mass of X upon molar mass of methane is a 16. Squaring both the sides, 4 mx molar mass of X upon 16. 4 into 16 is equal to molar mass of X, that is a 64 gram per mole. Let us see a 64 gram SO3, sulfur 32, 3 oxygen 48. This is 80 gram. This is not the correct answer. Carbon dioxide 44 gram per mole, ethane 30 gram per mole, SO2 32 plus 32 64. That's why D is the correct option. This is about the Graham's law of diffusion. Come to the question number 3. A liquid is in equilibrium with its vapor at its boiling point. On average, two phases have equal. Which these are two phases have equal which thing? Now look here. Liquid is in equilibrium with its vapor. Remember, dear students, here which phase? Liquid phase. Here this is gaseous phase, vapor phase. Now which thing remains the same? Now what is the definition of boiling point? The temperature at which liquid is in equilibrium with its vapor. Okay. Energy of liquid phase totally different than that of a vapor phase. Therefore, total energy is not the answer. Again, potential energy for liquid and for vapor are totally different. Here, temperature remains same. Temperature remains the same. And kinetic energy depends only on temperature. As boiling point temperature remains the same. Vapor phase, suppose water is the liquid, 100 degrees Celsius, liquid present, 100 degrees Celsius, vapor also present, equilibrium. Temperature of vapor phase and liquid remains same. Their kinetic energy also remains the same. C is the correct option. Intermolecular forces, wrong. Why? Intermolecular forces of attraction in a liquid less, and this intermolecular forces of attraction in vapor gaseous phase negligible. That's why this is again not the answer. Correct answer is kinetic energy. Question 4. A molecule of oxygen is 8 times heavier than that of hydrogen at 25 degrees Celsius. The average kinetic energy of oxygen molecule. Again, now look here. Temperature is constant. No doubt oxygen 16, hydrogen here 2, suppose here 8 times heavier than hydrogen. Oxygen 16 8 times heavier than this hydrogen. Now look here. Average kinetic energy is equal to 3 by 2 RT. This is for 1 mole. Then average kinetic energy is equal to 3 by 2 kT. This is for 1 molecule. For a molecule where K is equal to Boltzmann constant. Now temperature is here fixed. That's why the temperature remains the fixed. Molecule of oxygen no doubt heavier than hydrogen 8 times. The average kinetic energy of oxygen molecule is here same that of hydrogen gas because temperature remains the same. This is the correct option. 4 times greater, 1 by 4 times greater, 2 times greater, wrong. Question 5. What is the ratio of RMS velocity of methane gas at 627 degrees Celsius to sulfur dioxide gas at 127 degrees Celsius? Now formula of RMS velocity is equal to thrice RT upon M. R universal gas constant, T temperature, M molar mass of the gas. Here temperature changes and molar mass changes. 3R remains constant. 3R here remains constant. Therefore we can write V RMS methane upon V RMS of sulfur dioxide gas is equal to 3R gets cancelled. T 627 degrees Celsius is equal to 627 plus 273 is equal to 900 Kelvin. 900. Then what is the molar mass of a methane? Molar mass of methane is 16 divided by RMS velocity of SO2 gas. Temperature of SO2 gas 127 degrees Celsius plus 273. This is equal to 400 Kelvin. 400 upon molar mass of sulfur dioxide gas, 1 sulfur 32, 2 oxygen 32, total 64. Let us simplify this one. 900 square root of 900 into 64 upon 16 into 400. This gets cancelled. This gets cancelled. 16 gets cancelled. Root 9 is equal to 3 upon 1. Ratio is 3:1. B is the correct option. This is the ratio 3:1. Question 6. In an isoporic process, pressure becomes 2.5 times when temperature changes from. Now, what is the meaning of an isoporic process? Volume remains constant. Pressure becomes 2.5 times. Then what is the pressure change? Now, remember this is based on Gay-Lussac's law. At constant volume, pressure is directly proportional to temperature of the gas. P1 upon P2 is equal to T1 upon T2. Okay. P1 here suppose 1 unit initial, then it becomes final pressure 2.5 unit is equal to initial temperature T1 upon T2. Now as pressure changes from 1 to 2.5, temperature should also change from 1 to 2.5 times. Let us take which is the temperature that changes from 1 to this 2.5. Let us consider here 27 degrees Celsius is equal to 300 Kelvin. 477 degrees Celsius is equal to 477 plus 273. This is equal to 750 Kelvin. Now, what is the 300? If we multiply 300 by 2.5, we get this temperature. As pressure changes from 2.5 times, 1 to 2.5, then a temperature should changes from, if 300 Kelvin is the initial temperature, final temperature should be 750. A is the correct option. Remaining will not balance here, not match here. 30 degrees Celsius is equal to 303 Kelvin. It's a 2.5 times. 90 degree is a nothing but 90 degrees Celsius is a nothing but 363 Kelvin. This is not a 2.5 times. B is not the correct answer. 400 Kelvin to 900 Kelvin. 400 का 2.5 times कितना आएगा? This is 1000. ये भी wrong है. 100 डिग्री सेल्सियस का मीनिंग है 373 केल्विन. 300 का है 573 केल्विन. ये भी 2.5 टाइम्स नहीं है. Then A is the correct option. 27 degrees Celsius 300 Kelvin, 477 degrees Celsius 750. That means 2.5 times. A is the correct option. Then let us solve here. Question number 7. The temperature at which real gas behaves ideal gas over wide range of a pressure and a temperature. This temperature is called as the boil temperature. What is the boil temperature? The temperature at which real gas behaves ideal gas. over wide range of a pressure and temperature. That temperature is called as the boil temperature. Is the correct A is the correct option. What is the meaning of inversion temperature? The temperature, and instead of cooling, the gas is start to heat. That is called inversion temperature. This is not the correct option. Critical temperature, the maximum temperature at which the gas undergoes liquefaction. This is again not the correct one. None of this. This is not the answer. Boil temperature is the correct option. Question number 8. The ratio of VRMS, RMS velocity to average velocity of a gas molecule at a given temperature. Now let us write the formula of VRMS to V average for one molecule. For RMS velocity, just we already written here 3RT upon M. Upon average velocity 8RT upon pi M. Let us take this ratio. RT gets cancel, M gets cancel. We have here root 3 divided by root 8 upon pi. Pi is nothing but the 3.142, 22 upon 7. If now this is equal to, if you solve this one, this will become 1.086 as to 1. This is the ratio of RMS velocity to average velocity of a gas molecule at a particular temperature. Option A is the correct one.